Hi, everyone, and welcome to Database Security Office Hours for May of 2019. Our topic this month is Oracle Key Vault. Just a quick reminder, this call is being recorded, and the recording will be available on the AskTOM Database Security page at bit.ly/asktomdbsec. All you have to do is click All Sessions to view this recording plus previous month's sessions. Office hours, the reason we have this program is to give you a direct line into database security product development team. This is in addition to doing things through SRs, which will get filtered through support. We start each office hour session with a presentation on some technical topic. We'll finish up with an open line for any questions you might have. Feel free to enter your questions into chat at any time, and we'll get to those during the Q&A segment at the latter part of the office hours. A couple of quick product announcements. First one is Database 19C. We continue the release of Database 19C. Latest developments is at the end of last month, we released for on-premises. This is for Linux and Solaris Spark. So we now have 19C available for engineered systems, LiveSQL, which were previous months, Linux and Solaris Sparks. We also released last month, or actually not last month, but the first part of this month, the instant client for Linux. That's available now. And you'll see other operating system and cloud releases coming soon. A lot of new features in 19C. We've talked about those in previous sessions, things like operations control, enhancements to simulation mode, the syslog output for unified audit, but this is ready now. Upcoming events. If you're in India, we have the Oracle Groundbreakers Tour for 2019. We're speaking at 5 of those events, so we'll have product managers there. And more information, you can go to the URL you see on the screen. And believe it or not, Open World San Francisco is really getting close now. Registration opened last month, and last night the content catalog went live. So if you want to get a look at what sessions are going to be at Open World this year, go to oracle.com Open World and click on Content to see that. We'll have about 8 sessions that product managers are doing. I'm sorry, 9. We just picked up another one. We've got 6 mini theater sessions this year, and we're doing 4 hands-on labs. Really going to be a lot of database security content in Open World this year. Hope to see you there. In addition to Database 19C, we also have an update for Audit Vault and Database Firewall. Bundle Patch 10 is available. You can see the patch number on your screen. As always, bundle patches include the security fixes and any bug fixes. But from a feature standpoint, Bundle Patch 10 focuses on support for newer versions of different targets. We've updated our Linux support. We gave it updated for a new version of AIX. We added host monitor support for Windows. We're getting a lot of requests for that. And we tweaked our support for audit collection, firewall collection in SQL Server 2017. So if you're running Audit Vault and Database Firewall, take a look at this patch, and there's some nice new stuff in there. The big topic this month, though, is Oracle Key Vault, and we're going to get to 18.1 here in just a few minutes. There's a lot of new capabilities in that. The most significant one, Peter's going to spend a bunch of time talking about. I'll introduce him in just a second. But if you are running 12.2, there's 2 patches you should know about. One of those is Key Vault Bundle Patch 9, and I've got the patch number for that on the screen as well. There's no new features in this bundle patch. It's really just security and stability patches. The new features are in 18.1. If you want to upgrade from Key Vault 12.2 to 18.1, the upgrade patch is also listed here on the screen towards the bottom. And that's it for product announcements. I'd like to introduce Peter Wahl to you. Peter Wahl is the product manager for encryption and key management here at Oracle. Peter's been at Oracle for as long as I have, over 20 years now. And Peter has been my go-to person for anything around transparent data encryption or key management since we first introduced the feature back in Oracle 10G. His knowledge of how transparent data encryption works, how key management works is encyclopedic. I don't think I have ever come across a question where he either didn't know the answer or wasn't able to get it to me fairly quickly. So really, really honored to have Peter as our speaker this month. And with that, Peter, I am going to turn it over to you to take us through TDE, key management, and specifically Key Vault 18.
Okay, thank you very much, Russ. Welcome, everyone. I hope that you can hear me well. If not, please complain to the through the chat channel. Of course, I don't know if you have ever played with transparent data encryption, and that of course plays very well with Key Vault. So I'm going through a very quick intro of transparent data encryption. So what TDE does, it encrypts your table spaces in your database, and it does that at a very low layer of the software stack. So what TDE encrypts are the blocks of your data files, not the table spaces directly. It goes against the data files that make up your table space. And so on that level, we only see zeros and ones. We don't know exactly if that block that we just encrypt contains a table, an index, or whatever else is stored in your table spaces. We don't know that. That also implies that by the time the data is in database memory and is used by your end users, it's in clear text. And that means that your application users don't see a difference in terms of how responsive the application is, because it's the same thing. TDE doesn't interfere with the caching mechanism of your application and of your database, right? Because everything that the database deals with is in clear text. We only encrypt at the very last moment when we write the data into the data files. Where TDE kicks really in is when you separate the encrypted data from the encryption key, which is stored as close to the live data as possible. So when you create a backup or an export file, or when you lose your backup tape if it falls off a truck, then this is useless because the person who finds that backup doesn't have the encryption key. The encryption keys, you can see that on the picture here, they can be stored in Key Vault or in a local wallet. A local wallet is an encrypted file that contains the master encryption key, and that master encryption key encrypts the data encryption keys that are stored in your database. So that was a very quick walkthrough of TDE. I can talk about TDE for hours on end, but we don't have time for that today. And here is where key management comes in. So if you have many databases that are encrypted, keeping the encryption keys in a wallet is pretty secure, but from a management perspective, it can become a nightmare. The wallet is protected by a password. That password can be forgotten. The wallet file itself can be corrupted. And if you lose your key, the nature of encryption is no key, no decrypt. Your data is lost. So you really, really need to take care of your keys. It's very important. And also, more and more customers, specifically in the financial industry, they don't want their keys on the database server. I believe it's even a PCI requirement that the encryption keys need to be moved off your database server where the data is encrypted with that key. And as long as you have only 5 databases that use TDE, you maybe don't need Key Vault. But recently I heard from many large customers that they have to encrypt every single database that they have in their data center. There are no databases in their data center that are not encrypted. So we talk about 5,000, 8,000 databases, and all of them need to be encrypted, right? You cannot manage local wallets in that volume. So if you centralize that key management into a scalable key management platform, you have all your keys managed in one place by a small, trusted team of professionals that know how important those keys are, and they will take care of it. And OKV is the vehicle that helps them do that. OKV also automatically makes a backup of itself. Let's say every day you can configure this, And so if you ever lose OKV, then you can rebuild that OKV from the backup. It will be a clone with everything inside that you had in your original OKV, all your keys, all your preferences, all your settings, all your usernames and passwords for the administrators. Everything is the same except the IP address. That's another one. But everything else is exactly the same. And Oracle Key Vault does more than just TDE keys. You can connect MySQL databases to OKV. And if the MySQL databases are encrypted, they have an online connection into OKV. So again, there is no need for the keys to be stored locally on that server. If you have an ACFS file system, that can be encrypted. And again, that volume key can also be stored in OKV. And many other secret and sensitive files can be uploaded into OKV just to have them backed up regularly, right? So you don't lose, I mean, if you lose them, you can easily download them from OKV and you're back in business within minutes. And there is a wallet that moves into OKV. There are a few pain points in Oracle Key Vault 12c, and we addressed those specifically in OKV 18. So one of the features of 12.2 is that we implemented we implemented high availability by having an active primary and a passive standby OKV. If the primary goes down, the standby takes over. If the standby goes down, then the primary OKV will go into read-only mode. So this keeps your databases alive. They can still do their work. They cannot do wiki operations anymore, but you don't do that every day anyways. So your databases don't go down, but that's not really how you do key management today, right? You want your keys to be always available. And because there can be downtime from an OKV perspective, we came up with a persistent cache, which is a key store that is sitting on your database server. It is created and maintained by OKV, but it puts a key on your server, and that's exactly why that's exactly what we try to avoid. We want your keys off the server. So that persistent cache is something that our customers in the financial industry, usually they turn that off. And that makes OKV a single point of failure, and that is why we came up with a perfect solution in Oracle 18. So this is how a deployment looks like when you have the old OKV. You have a primary data center and a secondary data center. Let's say that your primary databases run in your primary data center and your DataGuard physical standby databases run in the secondary data center. All databases, primary and standby, connect to the Key Vault server on your left side of the screen on that primary OKV. And when that goes down, it takes a couple of minutes for the standby to promote itself as the new primary. And then all the databases connect transparently to the standby OKV. Now, if you are like most customers, you have an HA pair in your primary data center and an HA pair in your standby data center. So you have 4 OKVs. In this case, in order to keep that standby OKV pair up to date, you would regularly apply the backup that you generate from your primary OKV pair. You would restore it into the standby OKV pair. That's a more or less manual process, and again, not something that's not the way how you do key management. One highlight of OKV 12.2 is that the same OKV instance can manage your databases on-premise and in the Oracle Cloud. So you don't need a second one. One OKV can do both. Now we come to Key Vault 18c. So the most important feature of OKV 18 is that we provide continuous key availability. And we do this by allow clustering of OKV instances, up to 16. And I think that all 16 go down is very unlikely. So if one goes down, nothing will happen to your databases. They will keep on working and the keys are fully available. Also, after you deployed your key management system based on an OKV cluster, all updates or changes that you make to that OKV cluster no longer require downtime on your databases, right? Because if you have, say you have a cluster of 6 OKVs, if you need to patch them, you take one of them down, the other 5 will continue to serve your databases. They can do rekey operations, they can do everything as if the cluster would be complete. And when that node comes back on, it will find its place in the cluster completely by itself. There's nothing that you have to do except start that OKV. And it will be recognized by the other OKV as a valid participant in that cluster. And all the changes that have been applied to the remaining 5 nodes will be applied to that node that comes back automatically. So there's nothing that you have to do extra in terms of, oh, I need to reconnect it to the cluster. No, nothing. The only thing is you start that instance back up, and a couple of minutes later, it's fully integrated into the cluster again. You may know that we have a RESTful API. The RESTful API can be used for unattended, lights out, self-service, onboarding of databases into OKV. So what that means is, instead of, let's say you would like to connect 5,000 or 8,000 databases to an OKV cluster, you can either hire 20 people that do nothing else but sitting on the OKV web interface and register databases, or the OKV administrators create a simple set of scripts that they make available for the DBAs to download from some shared file system. The DBAs download, they run the script, and 15 seconds later, that database is registered with OKV, and the DBAs can start encrypting their database. So that's, of course, that's a very handy tool when it comes to mass deployment of OKV. With an OKV 18 cluster, the persistent cache is no longer a requirement to keep your databases up, because your databases will always find at least one OKV instance that is up and running, right, out of a cluster. We still support the persistent cache, and there's no plan to not do this anymore. In this case, the primary use case for the persistent cache becomes to reduce the network traffic, and by doing this, also reducing the load on OKV. Because some of the requests that a database launches against OKV can be satisfied by a persistent cache. So if you experience that your network load goes up because your databases are very busy, then you may think about implementing a persistent cache. So that depends on your use case and on your situation and how on your database load and all these things. So Oracle Keyword 18 really moves the needle for key management, because no other key manager can do what we can do, right? We promise that your encryption keys are continuously available. We support basically any number of databases that are encrypted. And again, the other key managers will run out of steam at one point. If this happens with OKV, you just add a few nodes and you're back in business. Yeah, it's basic, and it's also tested with all these sophisticated tricks that your DBAs do with your database. So they clone databases, they relocate PDBs, we have DataGuard, we have Active DataGuard, we have all these things. And the HSM providers always have trouble following us in the latest developments of our database technology. So they don't really support RAG, they have problems with DataGuard and all these things. So it's not really optimized. When you bring in OKV into an environment that is already encrypted with TDE, you will find that your life becomes easier, because OKV simplifies the operations that you need to change when you encrypt your data. Yeah. I give you one example. If you have, excuse me, if you have a standby database and a primary database, and both of them are encrypted, and you use a local wallet, if you do a wiki operation on your primary, the MRP on your standby database will stop because it doesn't have the key. So you need to copy the wallet over to the standby and restart the MRP. That's not a big deal if you have only one standby database. Now, Oracle supports up to 30-something standby databases per primary database. If the MRP goes down on 30 databases and you have to restart the MRP 30 times, that's a different story. Now, if you connect all those standby databases to the same virtual wallet in OKV that is owned by the primary database, when all those databases share the same keys in OKV, and you do a wiki operation on your primary database, the standby databases know where to get that new key because it's in OKV and they have access to it. And they will apply that key, that new key, to the incoming data from your primary database that is encrypted with the new key, and they have that key, and everything is fine. It's just, it is almost like nothing is encrypted. That is how transparent this becomes when OKV is added into the picture. So that's again our unique product differentiators. We not only provide key management for MySQL and Oracle database, you can put all kinds of secrets into OKV and they are professionally managed. Right? We have the continuous key availability, the self-service onboarding of databases to OKV, and OKV runs on Oracle. So the operating system is Oracle Linux 6 update 10. The embedded database is Oracle 18.6, which means we applied the April 2019 patch a couple days before we released OKV 18.1. And then, of course, we have software that runs in there. And this is all created by Oracle. So it's Oracle on Oracle for Oracle. So how does Key Vault work? And I think it's even easier if I go to the next slide where I have this little build. How do we deploy a Key Vault cluster? So the first step is we need a new node of Oracle Key Vault 18. If you are already using Key Vault 12.2 and you would like to upgrade, this node 1 is the upgraded version of your existing Key Vault. If you had Key Vault installed in an HA pair with a primary and standby OKV in 12.2, you break that HA and you upgrade your primary OKV from 12.2 to 18.1, and this becomes your first node. Then you build another OKV. That's a fresh install. And as you pair them, the content from node 1 will automatically be transferred into node 2. So all your keys, usernames, settings, passwords, DNS addresses, NTP addresses, everything, the whole set will be copied into node 2. And when we're done copying, this will be what we call a read-write pair. So now your databases can connect to any of those two nodes, and they will keep each other synchronized asynchronously. So when you connect your database, or when your database connects to node 2 and you do a set key operation, that new key is created by OKV number 2 and copied over to node 1. So when you select from encrypted data next time, your database can connect either to node 1 or to node 2. It has the same key. So that is why we can say the keys are always available on at least one more OKV. Now, if you would like to extend your cluster, you build another new OKV, right? You install from the installation media that gives you a new OKV. And then you connect that to the existing read-write pair. That gives us a read-only node. So node 3 for now is a read-only node. Now we add another one. Again, a fresh install of OKV. And the controller node for node 4 is node 3. So now node 3 has all your keys, and node 3 will copy the content into node 4. And when it's done copying, all 4 OKVs have the same content. And boom, there we have our second read-write pair. So node 1 and node 2, and node 3 and 4 are 2 read-write pairs. Those keep each other in sync synchronously. And between the read-write pairs, the data is updated asynchronously. So what you can do is, if those 4 nodes are really busy and you like to create regular updates, say 3-4 times a day, so that no keys are lost, you could establish another keyboard. That would be a read-only node that cannot be modified by a database connection, but it will still be updated by all the read-write pairs. So all the keys will be in node 5 very quickly after they have been created in any one of the read-write pairs. And you could basically run the backup procedure on node 5, so that you don't put the burden of running the backup on any of your production nodes. You could outsource the backup of that whole cluster into an extra node if you want to. So this is just an example on how it looks like. You can imagine if you have 16 nodes, we get a lot of errors. Okay, if node 2 goes down, node 1, because it doesn't have a matching read-write peer anymore, will become a read-only node. Your databases that connected to node 2 will automatically connect to any other node as long as they only need to read a key, right? To read a key, they can connect to node 1, 3, 4, and 5. If you do a set key operation, then they can only connect to node 3 and 4, and the databases will do that automatically. There's a configuration file on your database that contains the IP addresses of your active nodes. And when a node goes down, that list of IP addresses will be automatically updated, and that IP address will be missing in your file. So your databases won't even try to connect to the node that is down. And when your node comes back, the list of IP addresses in your database clients will be updated that, hey, node 2 is back, and then your databases will connect to it again. So a quick live demonstration. Russ, I believe you need to stop sharing for a moment. Thank you. And let me share my screen. We don't need this anymore. So, okay. So you can see here I have 4 OKVs running, and if I try to click anywhere, most likely I will be, oh, I don't even have to log in. So there's a new tab in OKV 18 down up here that says cluster. And there we see my 4 OKVs. OKV 1 and 2 is a read-write pair, and OKV 3 and 4 is a read-write pair. And I have cluster subgroups, north and south. Those subgroups determine the connection affinity of your databases. So your databases in the south data center will connect to the south OKV read-write pair, and the other databases will connect to the north data center if they are in that same data center. But they don't have to. If one of the OKVs in the north data center goes down, your databases from up there will connect to the south OKVs without you noticing it. Right? It's transparent. They fall over transparently. So if we go here to the home page, we see that currently all my OKVs have 56 keys, right? And all 4 of them have the same content because it always gets synchronized. So what I will be doing is I will be shutting down one OKV, OKV 01, and then we will do a set key operation, which normally will fail, but with an OKV cluster, everything will go through. So we exit from here, and to prove, yes, please.
What is that identified by external store?
Oh, that's a new feature in Oracle Database 12.2 and later. That allows for complete separation of duties in terms of DBAs knowing any OKV passwords. Because that password that you usually use here is also the password that protects the access into OKV by a tool called OKV-util. OKV-util is used to upload your keys into OKV, to do things like this, and you can also download. So if a DBA knows that password, he can also use OKV-util to download the wallet, and maybe you don't want this. That is why we can hide that password from the DBA, and he can do all key management operations that he needs to do, rekey operations and all these things, without knowing the OKV password.
Thanks.
You're welcome. So this is OKV01. I will now go and pull the plug on that virtual machine. So I will power off. Okay, that key vault is gone. If I try to ping it, there's nothing coming back. So that OKV is dead. I can log into my database and I can do my set key operation, and that will take a moment. One, because we have to update the other OKV servers. It's no longer only one, right? There's one OKV that creates a key for us, and that key needs to be copied to all the other nodes. Now, the specific setup that I have here with 4 OKVs and 2 databases running in virtual machines on one laptop makes that whole thing really, really slow. I have enough memory, but still, everything I do takes a little while, as you can see. The important point is there are no error messages. Your database doesn't go down. We're just waiting for the new key, that's all. Right? If there are applications connected to your database, they will continue until we get the new key. Then we rekey the data encryption keys. Everything happens behind the scenes. That's all transparent. The point is we don't get an error message. Your database doesn't go down. Nothing happens, right? We're just waiting for OKV to be ready to give us the new key. So, and it should be coming back very soon. And then we have 2 new keys in OKV, because this is a container database with one pluggable database. And when I specify container equals all, I create a new key for the container database and for the pluggable database. So maybe that's another reason why it takes so long, because we have to do the whole thing twice, right? 2 new keys, 2 updates to all OKV servers. Maybe that plays a role too. So when we check next time, we should see 58 keys in OKV, and in all of them, in all 3, in all the surviving nodes. Okay, so here's our new key. Let's go to OKV number 2. 58 keys. OKV number 3, 58 keys. OKV number 4, update 58 keys. OKV number 1, that won't do anything because OKV number 1 is down. Okay, so the important thing is we could continue as if nothing happened, even though 25% of our OKV servers were unavailable. So when I start, and I'm doing this for the 3rd time now, when I start this OKV back up, it will find its place in the cluster, and when I check in a couple minutes, if I check back, then I will see 58 keys in OKV01. So all this happens transparently. So I'm done sharing. I stop share, and then I should see the presentation again. Russ, can you share your screen?
Let me, no, I have to go back and reshare, so give me just a second.
Uh-huh.
All right, so I've got that done, and I need to give you control again. All right, you should have it, Peter.
Yes, I got it. Okay, so let's carefully click. Come on. No, it's not moving. Oh yes, here it does. Okay, so here we see a screenshot of what we just saw live. I put this in case my demo dies, but it survived. So that's a screenshot of the cluster management screen of your OKV cluster. So if we go to the next one, come on. Oh, here we go. Okay, so the, the other new key features of OKV I already talked about, that we extended the RESTful API to not only allow you a simplified mass deployment of any number of databases into OKV. The RESTful API in OKV 18 can also do key management operations. So now you can do OKV util set key or register key, and then your databases will use that key. So you can do that from a script, basically, from outside of the database. Also, you can turn on FIPS inside OKV after you installed it, or you can decide to install OKV in FIPS mode, so then you don't have to worry about that afterwards. What happens when you turn on FIPS is that we switch the operating system to run in FIPS mode, which means we replace the SSH keys with keys that are FIPS compliant. The initial RAM disk that the operating system needs to boot will be FIPS compliant, and so we can make a statement to say that the whole operating system runs in FIPS mode. We also turn on dbFIPS 140 in the database, and there are components in a Golden Gate, which is used to replicate the content of OKV from one OKV node to the other. There are components in an Oracle Golden Gate that can be switched to run in FIPS mode, and we do that too. So we turn all these things on, and that is why you can do that at install time or afterwards. After you install, there's a check mark, there's a checkbox on one of those OKV pages. You click it, and then we make the changes inside OKV. And as I said, the embedded database is 18.6. Here is a simplified a diagram on how to use one OKV instance or one OKV cluster to provide key management to your on-premise databases and to your cloud databases. We establish an SSH tunnel into your cloud environment and go from there. And that's where we find the keys and can manage the encryption keys from your databases. And this basically enables what the cloud security best practices tell us. If I put my databases on somebody else's computer, I don't want the encryption keys on the same computer or the same cloud provider. I would like to control my keys myself because they're just too important. And there's also a nice feature in OKV that allows you to turn off all your databases or to turn off access to your databases with one click of a button. There is a suspend button in your OKV pages where we list the endpoints, and you can highlight all endpoints and click suspend, and from that moment on your databases won't have access into OKV to get their keys. So if you are alerted that somebody is in your environment and is hacking your databases, you can turn them all off with one click of a button. And when you know what was going on, when the intruder has been pushed out of your network and everything is good again, then you push that button again and all your databases are re-enabled within moments. So here is a collection of the possible use cases. What you saw in my little demo is the far left use case where we have an online master key into a database, between a database and OKV. The other use case over that is we also support uploading and downloading of the wallet. So your databases keep using the local wallet, but you upload the wallet into OKV to have a backup. Just in case the file gets corrupted, you can download from OKV and you're back. On the next the next two use cases, you can upload and download Java key stores and other credential files. Your MySQL databases connect into OKV. Starting from Solaris version 11.3, we support that you put the Java crypto keys into OKV. And if you have an encrypted ACFS file system, you can put the volume keys into OKV. So OKV broadens its reach into the Oracle infrastructure. There are more and more places where key management with OKV makes sense. So for example, here's a new one that I believe is not even documented. Our ZDLRA will allow to store the RMAN backup that it creates in cloud storage. And of course, before you do that, you want this RMAN backup to be encrypted. And the Zero Data Loss Recovery appliance automatically talks to OKV for key exchanges so that we have a properly protected encryption key when we encrypt the RMAN backups that get stored in the cloud. So that's a new feature. Another new use case for OKV has been implemented by a patch for a customer who couldn't wait, but it's a planned feature for the next major release of Golden Gate, and that is that Golden Gate will transparently encrypt the files that it extracts from your target before they get applied to your standby, the trace files. And they will be encrypted by Golden Gate transparently, so they will no longer be stored in the clear. And in order to achieve this, Golden Gate talks to OKV for key management. So there are more and more use cases where, again, our competitors don't have access to. Right? They don't know how to do these things, and you certainly make OKV. So if you spend money in OKV, we try to make it valuable to you, so that you spend your money in a good place, and you can use Key Vault in many more places than only protect your encrypted databases. On this slide, we see how we integrate with an HSM. We did this because specifically our customers in the financial industry, they have a requirement that everything they do hangs off an HSM. And we cannot connect hundreds or thousands of databases to an HSM. The HSM will be too slow. They have a certain limited a number of CPUs, RAM, disk space, all these things. And they are too slow. They are very secure, but they are too slow to handle a big load of encrypted databases. So what we do is we put Oracle Key Vault between the HSMs and the encrypted databases. So Key Vault cluster does the heavy lifting of key management for your databases, and OKV itself is protected by an HSM. So from a legal perspective, if a financial customer says everything needs to be connected to an HSM, yep, here we go. We have OKV protected by an HSM, and then the databases hang off OKV to do key management. And there are no keys from OKV in the HSM, right? All your database keys are in OKV, and only the password that is needed to make TDE inside OKV available, that password is stored in an HSM. So if somebody walks away with your OKV server, if you have it installed on a virtual machine, it would be rather easy. I just copy the data files onto memory stick and I walk home. And then I have your OKV server on my memory stick. And hey, I can start and have all my keys. No, you don't, because that OKV will not start without connection to the HSM. So that's an additional protection against theft of the Key Vault server. So far we have certified 2 different HSMs to provide this, what we call a root of trust. There's a SafeNet Luna 7000 and the N-Cipher N-Shield 6000. Those are the two HSMs that we have certified with for root of trust. So that was my presentation so far. Russ, back to you.
Thank you, Peter. Just a quick note before we move into questions and answers. I want to thank you all for attending today, and I look forward to seeing you next month. AskTOM Office Hours will be on Thursday, the 13th of June, and right now our topic is scheduled to be advanced data masking formats. This is part 2 of the session we did in April, and on this next session we'll be covering things like grouped masking, conditional masking, just a little bit more of the things you can do with data masking and subsetting. So again, I hope to see you next month on Thursday, the 13th of June. And now let's turn to Q&A.
And Peter, several questions came in on chat while you were talking. A few of those I did my best to answer, but I want to run through them so you can see if I missed anything, and any amplification. And then there's a couple of questions that we didn't get to in chat. So Rashmi asks, if a data file is encrypted with TDE and we run RMAN backup, does it have to decrypt the data before taking a backup of the blocks? And my answer is that RMAN recognizes the blocks are encrypted them and copies them to the new backup already in their encrypted form so that encryption follows the backups of the database.
Yes, there is a little nuance to this. If you don't switch RMAN encryption on, then this is correct. Encrypted table spaces will be passed through into the RMAN backup encrypted. Clear text table spaces will remain encrypted. If you turn on encryption in RMAN, then all table spaces, clear text or encrypted table spaces in your database will be encrypted in your RMAN backup. If you turn on compression and encryption in RMAN, then all table spaces will be encrypted because we compress them first. In order to compress them first, we have to decrypt. After decryption and compressing, we don't remember exactly which table space was encrypted or not, so we encrypt all of them. Which also means that if you do all this in the right sequence, you can compress your encrypted backups, or you can compress first and then encrypt. And that is how you don't lose any compression benefits.
Outstanding, thanks. And then Raj asked a follow-up question. What happens when we restore the encrypted RMAN backup to a new database or clone instance? And I responded that the clone will also retain the encryption and will need access to the same master key used to encrypt the original database. What I didn't say is how wonderful it is to have Key Vault in that case because you're not copying wallets and trying to keep them in sync.
Exactly. This is one of the big features of OKV, that we allow sharing of keys between endpoints. If you want this, right? By default, of course, only that endpoint who owns the key has access to the key. But if you would like to clone a database to another server, you give that other server access to the same key, to the same wallet in OKV, and then the restore will be as if nothing would be encrypted. There's no difference.
Wonderful. Rashmi asked a couple of follow-up questions. He asked, does Key Vault Active Passive use some kind of cluster storage? And my response there is Active Passive, the older 12C architecture, uses DataGuard in the background.
Mm-hmm.
And then, of course, the inevitable, if that's the case, how does multi-master work, or what's the standard there? And what I said is that we're using Golden Gate in the background for multi-master.
Mm-hmm.
One of the great things is we've gone from 2 nodes to 16, which your chances of having all 16 nodes fail is almost non-existent.
Yes, exactly.
Let's see. Chris asked a great question about licensing. We're using Golden Gate. Does that mean they have to license Golden Gate? And what I responded is that we're including a limited use, or restricted use is what I should have said, Chris, by the way, is restricted use is the legal term, for Golden Gate, and I gave you a link to the documentation for that restricted use.
Yes, that is correct. We didn't license for DataGuard in 12.2, so that was a runtime license as well.
It's true, we had active DataGuard license there. Let's see. Going down, we're getting to some that I didn't get to. Raj asked a question, after restoring or syncing the key from backup, the dead Key Vault node will come up online, right? And Raj, we may need to get you to amplify that a little bit, but Peter, can you pick up the question from what Raj asked?
Can you say the question again? I didn't
Sure.
really understand what the question was. I'm sorry.
So what Raj typed in was, after restoring or syncing the key from backup, the dead key vault node would come back up online.
That's not a question, that's a statement. And yes, if I would restart OKV01, the one that I killed 15 minutes earlier, it would find its place in the cluster and would be upgraded and would become fully functional within a few minutes. Yes.
Okay. Raj, did that answer your question? Yes, Raj says yes. Okay.
Okay, good.
Let's see. And then Flora asked, does Key Vault provide functionalities to enhance integration with Cloud at Customer? For example, when a database is created on Cloud at Customer using the control plane, its wallet is stored on the file system. Is there Key Vault functionality to fetch and store the wallet in OKV?
If you have access to the operating system, or if somebody, either the Oracle Cloud people, then you file a service request and they do this for you, or you, the customer, has access to the operating system in Cloud at Customer, you can certainly install the OKV client on that server and then migrate your database to OKV. That's a really good choice, because I think all security people agree with me that if I put my data on somebody else's computer, which is what I do in cloud computing, I really want my encryption keys under my control, right? That's the last thing that I want somebody else to have. So putting my keys into Key Vault on-premise and then have it reach out to all databases, on-premise, hybrid, and cloud, and customer, and a Cloud at Customer, is a big benefit of OKV, that you have your key, all your keys, not only your database keys, operating system, and all the other use cases that we have. All the keys are managed in one big device, managed by a small trusted group, and yeah, that's it. Your keys are in one place in good hands.
And Flora, just to add to what Peter said, I've actually worked this use case myself with a couple of people. We do have customers doing ExaCloud at Customer with Key Vault. It really, from our standpoint as the Key Vault people, it's no different than any other Exadata that's on premises, because that Cloud at Customer box is running on your network. It's not on a separate network. And so we treat it the exact same way as if it were your Exadata. If you're running it in the cloud, Peter gave a great example of this during his presentation, and that's what we call the hybrid model, where you're running your Key Vault on premises and you're running Exa in the cloud. You still can use Key Vault up there, but then it's a remote network rather than using your local network. There's one more question, and this is again from Raj. How does this whole Key Vault architecture impact overall database performance in terms of backup, data selection, and connections to the database?
There is no difference, because in comparison to HSMs, OKV is a key manager. We don't have a FIPS boundary. Our keys can leave the device. So that gives us the liberty to cache the master keys for your database in the memory of the library. That's a little bit detailed, but what that means is that the database doesn't need to reach out to OKV all the time. Most requests from the database where the database needs a key can be satisfied by reaching out to the memory cache. That is different from the persistent cache that I talked about. It's a memory cache that is in your database memory, where we keep that master key. And so query performance should be identical to clear text.
Outstanding. Let's see. Jim asks, is there a date for the next Audit Vault version? And that was from the announcements at the start. And what I said was we're targeting towards the end of the year, but there's a lot of changes that come in that can always slip. So it's really too early to firm that up anymore, but we'll know more around the open world timeframe. We also got asked if there was a host size template for Key Vault like there is for Audit Vault. And my answer to that is we don't have a sizing template out for Key Vault yet. but we do have sizing guidelines in the installation guide. And
Yes.
if you look in chat, you'll see a link for those sizing guidelines. And Peter, that was it for what's come through in chat. If anyone has questions, feel free to enter them into chat or to just unmute yourself and ask them verbally. All right, no questions. Peter, thank you so much for giving us some of your time.
Of course. Thank you for having me.
And really excited to see this new version of Key Vault out. We've also got some of the development team on the call, and I want to thank them. This is we've been anxiously looking forward to this new version of Key Vault for quite a while. It's an amazing feat you guys have done to give us something that is so capable and with so much variety in the ways that we can deploy this. I can't wait to see this get out there a little bit more widely. So with that, I'm going to go ahead and stop the recording.